So hello everyone. So the topic that we're going to look at is on selective repeat ARQ protocol, but we will quickly recap go back in ARQ, right, and then take it forward of how selective repeat tries to address the issues in go back in ARQ approach. So before that, let me tabulate the differences in the three ARQ protocols that we were discussing. So the first one was stop and wait ARQ approach, right? The second one was go back N ARQ, right? And the third protocol of ARQ, right, is called selective repeat ARQ. So the fundamental difference in these three approaches is, sorry, yeah. So is the first one is we introduced the concept of window, right? It's the sliding window, which we will discuss more in the go back N and the selective repeat, right? So ideally in stop and wait, you're sending only one frame, stop and wait for an acknowledgement, right? So the flow control is already there, error control also we have brought in, but we're only sending one frame at a time, right? So the window here is how many frames or how many slots of frames that you can transmit. So in stop and wait, the sender window size is just one. It's only sending one frame at a time before stopping and waiting for the acknowledgement, right? But in the case of go back N, the sender window size is 2 power m minus 1. Why it's not 2 power m and why it's 2 power m minus 1? Again, we will look at that, but it can now pump more frames. What is m here? M is the number of bits for the sequence number field, right? So number of bits for the sequence number. So if I'm using 4-bit sequence numbering, then my frames will be numbered from 0 to 15. The window size of the sender is 15 frames, not 16 frames, 15 frames. So you can pump 15 frames before stopping worrying for the acknowledgement. That's the max window size. But these windows could slide through as it gets the acknowledgement to accommodate the future frames, right? So the sender window size is 2 power m, 1 less than 2 power m. But now let's look at from the receiver side. So the receiver side window size, as you know, in stop and wait, the receiver expects one frame at a time. So the window again is one there. So he sends one frame, he expects that frame, right? And he expects when send the next frame, he expects the next frame, right? So it's just one frame processing at a time, right? Go back N is just an improvement stop and wait to improve the bandwidth utilization by pumping in more frames. You don't waste your channel utilization like your stop and wait ARQ. So if you remember, we looked at something called as a bandwidth delay product, right? How are you filling the pipe, the volume of the pipe, right? The delay is your, the propagation time, right? So the round trip time to expect an acknowledgement. So if you are fully filling the pipe before you stop and worry for the acknowledgement, you're maximizing your bandwidth utilization. So go back and what does it do is it just tries to, address the issue of stop and wait in terms of poor channel utilization by bringing in this window concept of pumping in more frames of up to the order of 2 power m, 1 less than 2 power m minus 1. But please understand, the receiver algorithm of go back N is the same as a stop and wait. Receiver is expecting one frame at a time. If he gets that frame in order, he will process that frame and deliver that frame to the network layer of the receiver. Otherwise, he's going to discard out of order frames. So we'll understand how this might affect the performance when it's a noisy channel. Okay, so that has been addressed in selective repeat, where unlike your go back in, it is not a very large window size of 1 less than 2 power m, but it is only half of 2 of m, right? Half of 2 of m, which we can rewrite it as 2 power m minus 1. So the sender window size is only half of 2 power m. It's like half filling the pipe, right? Not as in go back in, but we will understand why it's quite less in filling the pipe compared to go back in, but it increases the channel utilization. But it also has fewer duplicates to compensate because the receiver algorithm is very complex in selective repeat. That is also of the same window size as the sender, right? So we will look at how this addresses, right? So I want you to summarize the differences in the window size. The second thing is, you know that ARQ protocols incorporates the concept of timer because it waits for an acknowledgement. If it does not get an acknowledgement, the timer times or it has to retransmit. But the entire protocol here maintains just one timer. It starts the timer, stops the timer when it gets an acknowledgement. If it does not get an acknowledgement, timer times out. It restarts the timer and resends that frame. But here it has only one frame to handle at a time. But here in go back in, since it's just an improvement in stop and wait, the receiver side algorithm is exactly the same. The sender side algorithm only has this window concept, but for every window, it's maintaining only one timer, right? So it starts when it starts the first frame in that window, it starts the timer, but it has to keep track, multiple frames that is done. But let's look at how that basically works. So there's only one timer maintained go back in ARQ protocol, one timer for every window that it tracks. It basically uses this one timer. But in selective repeat, the difference is there is one timer for every frame. For every individual frame, you're individually tracking that frame. So that is the complexity that you're trying to bring in, right? So we will understand how that works. And the use of acknowledgement that you saw here, in stop and wait, yes, you're looking for a positive acknowledgement, and the acknowledgement is always asking for the next frame to send. Go back in again, incorporates the same idea, asking for the next frame to send. But sometimes these acknowledgement can also act as cumulative acknowledgement. So cumulative acknowledgement's idea is introduced in go back in itself, but it is very well incorporated of the idea of cumulative acknowledgement in selective repeat. So there's a concept of positive acknowledgement where it could send one acknowledgement which serves as a cumulative to all the frames that it has received. So that idea is fully implemented in selective repeat, but it also has introduced a concept called negative acknowledgement, NAK. So in addition to positive acknowledgement, in selective repeat, selectively only repeating the frame which I have not got, right, retransmitting that frame through the receiver asking, hey, I need this frame here, I have not got that frame, by specifying that selective frame through a negative acknowledgement type. Okay, so this concept is introduced. So I want you to introduce that selective repeat has both a cumulative acknowledgement, asking for the next frame to send, which can serve as a cumulative for all the frames that is received. And it also asks for negative acknowledgement to selectively retransmit only that particular frame. So let's get on now and quickly look at go back in before we start with selective repeat, so that those who have missed the class of go back in can also understand that. So when it comes to go back in, we're introducing the concept of pipelining. So pipelining is the idea where you're trying to bring in parallel processing, right? So which means before one task is completed, you start the next task, right? In stop and wait, you know that for every task you want it to complete before you start the next task. So there is no pipelining in stop and wait. But in go back in, you could, before you get the status of your previous frames that you've transmitted, you can transmit your DEX frame. So that is the idea. So what happens is you are trying to increase the utilization of your channel by having several frames in the channel transmitted, which means the number of bits in the channel that is in transition is large. And so if you compute that with the volume of the pipe that you're filling, you're starting to improve your efficiency with respect to the bandwidth delay product, right? So that's the idea behind pipelining. So in go back in ARQ, you're trying to fill the pipe where you're going to have multiple frames that you're going to transmit without stopping or worrying for the acknowledgement. Okay, so we're going to call these as outstanding frames. What do you mean by outstanding frames is the frames that are already transmitted over the channel, but you are waiting for the status of that channel, status of that frame. You don't know what happened to that frame, right? So, but the only intention now is you want to occupy and keep the increase the utilization of the channel, keep the channel busy, not the channel idle, right? Before the sender can stop and wait for the acknowledgement. But the only challenge now is, since you're transmitting multiple frames, right? If you have to retransmit those frames, you need to keep a copy of all the frames in the buffer until the acknowledgements arrives. So to bring in this concept of how many frames that you can transmit without worrying for the acknowledgement, right? We are again going to start numbering the frames. And as you know, we have the sequence number field where you go on to have m bits, say, assigned for the sequence number. Then your range of sequence numbers for the frames would be from 0 to 2 power m minus 1, right? But then the important concept here is, okay, sir, how many frames you can pump, right, without stopping and worrying for the acknowledgement, right, is where we bring in this abstract concept called window. A window is basically an imaginary box, right, which tells you, hey, how many data frames you could transmit, right, without stopping and worrying for the acknowledgement. What's the max that you can do? So that window size is a fixed window size for the sender, right? And this window will slide that many number of slots, right, when it gets an acknowledgement, right? So we will look at how this works. So there is a window that the sender maintains, and that window the sender will slide when it receives the acknowledgement of those frames that it transmitted. How many slots it can slide depends upon the acknowledgement number that he gets, right? That many number of slots he can slide. The receiver again has a window that he keeps sliding as and when he expects the next frame, his window can keep moving. So when it comes to go back in, the size of the sender window is 1 less than 2 power m. And this is a fixed window size. So if I'm using 3-bit sequence number, then my window size of the sender is 7, which means I can send 7 slots are there. I can accommodate 7 frames, right? 7 data units from the network layer, 7 packets from the network layer, make frames out of it and transmit 7 frames without stopping worrying for the acknowledgement. That's the max. Okay. So having said, to track this, how many frames I've transmitted, have I reached my max window size, right? We are going to have 3 variables tracking this, sender window. One is SF. SF stands for the first outstanding frame, right? Your first frame that you have transmitted is your first outstanding frame. And every time you keep sending your frame, you have to keep incrementing the next sequence number, right, for the next frame to transmit. So SN keeps incrementing, but you can go on and keep transmitting that many number of frames till you reach the fixed size of 7 in the case M is 3. So 3 variables to track this. So if you look at now this picture, you will be able to understand what is this 3 variables and how you're tracking now. So in this case, if you look at every slot, you see that I can accommodate a frame, right? And the gray box that you see here is the window, right? So in this particular example, the window size that you see, can anyone tell me what is the window size? If you look at here, the window size is basically 15, right? So the M value, the number of bits that I've used for my sequence numbering here is, it's a 4-bit sequence number. Yes or no? So which basically means my sequence number will be from 0 to 2 to the power of 4 minus 1, right? So which basically is 0 to 15. But the window size is not 16 for the sender and go back in, it's only 15. So if you look at the window that I can maximum transmit is 15 frames, of which if you look at the first frame that I have transmitted, right, is called the first outstanding frame. I'm tracking that with the SF variable. And every time I keep transmitting my next frame till I fill the window, my SN value keeps incrementing. So SN is the next frame that I can send. So my SN keeps incrementing till I can maximum send up to 15 frames. So till the size of the window, which is S size variable. So if you look at here, there are different colors, right? There are orange colored slots, which means that all these frames I've already transmitted in the channel. These are outstanding frames, right? Which means I have transmitted those frames. These are outstanding frames, but I do not know the status of the frames that I've sent. Okay. So the white color slots that you see here are still the frames that I can keep sending, but I have not received it from the network layer, right, to make a frame out of it and transmit, but I could still process that till the window size. Okay, but now look at this. This is the window, right? But why is it called sliding window? When I can slide the window, only when I get the status of my outstanding frames, then only I can slide the window. So if I've sent now these 7 frames and say the receiver is asking, say, come on here, send me the frame, the 7th frame, right? Asking for frame number 7, then I could slide by 7 slots, right? Which basically means I've got the status of all the frames. I could slide by 7 slots and I could start now accepting the next set of frames, which again would have been, starting with a sequence number there. but my max window is, 15 that I have. So how many slots I slide? If I slide by one slot, I've got one acknowledgement of my first outstanding frame. But if I'm getting an acknowledgement asking for cumulative value, then I could slide as many number of slots that I can have. So that's why it's called sliding window concept. So if you look at the window is slided now by 3 slots, right? Because I've got the status of 0, 1, and 2. And I could now start accommodating the other future frames and accordingly number them. So this is the fixed window that keeps sliding as and when you get acknowledgement of the outstanding frames. Now, having said, understood the sender window, and the sender window can slide one or more slots when a valid acknowledgement arrives. So this is the fundamental difference compared to stop and wait, where it is only sending one slot, one frame at a time. Here you could send multiple frames. But the receiver side is the same concept as stop and wait, right? It is only expecting one frame at a time. It is expecting the next frame, and the variable Rn is going to track what is the next frame that the receiver is expecting and slides when that particular frame is received. So it is only moving one slot at a time and is expecting only that frame in order. So if you look at this particular picture, you will understand that there is this window size is 1. As your stop and wait, it expects in order frames. Now, receiver is expecting frame 3. If it gets frame 3, it slides by one slot and expects frame 4, right? And it goes on like that. But if you are getting out of order frames, the receiver will not accept it. Out of order frames are going to be discarded. That is typically will be the challenge or the drawback that we will see in the go back in approach. Okay, so let's now look at this. I hope you're able to follow so far the concept of window, the sender window, the receiver window in go back in approach. So how does it work algorithmically here is compared to your stop and wait, what you see is the receiver side, there is no change. It's expecting one slot at a time, one frame at a time. But in the sender side, you have one timer event that is going to be tracking the frames that you have transmitted, right? And if you get an acknowledgement, you can stop the timer. When you're sending the next frame, you can start the timer and it goes like that. So there is going to be a notification event from the physical layer if acknowledgement comes. And there's going to be a request from the network layer for getting the data, making a frame out of it, and transmitting the frame. But you can keep filling till as many number of frames till the window size that is there. So having said there's only one timer for this protocol, and you start sending the first outstanding frame, you start your timer, and you keep sending your other frames as in your window. You could keep filling it up. But having said, sir, why are you saying the window size is 1 less than 2 power m and not 2 power m only? So we will look at this approach, why this window size is chosen by looking at this scenario. So all of you look at now this left-hand side picture. Okay. So here the window size is chosen. Now, can you tell me what is the value of the number of bits that I've used for the sequence numbering here? Right. What is the value of yum that we have chosen here? Can anyone tell me? So if you look at the sequence numbers are 0, 1, 2, 3, right? And the window is basically size 3. Right. So what could be the value of yum that you choose number of bits for the sequence numbering? So if you choose yum as 2 bits, right, your sequence number is going to be from 0 to 3. And then again, it recycles from 0 to 3, right? So it goes like that. So here the window size is 3, which is 1 less than 2 power m. This is the correct window size that we are talking about. But what will happen if I choose a larger window like 2 power m, which is window 4? This is the what we are going to analyze. So here in this case, there is an assumption. It's a very worst case scenario. So what is the worst case that could happen here? Your forward channel, if you see all your data frames are correctly being received, there is no errors. But the reverse channel where the acknowledgement is being sent by the receiver, they are all getting lost. This is the worst case. Under that scenario, we will see what is happening. So let's look at this now. The sender has a window of 3, which means he can pump 3 frames without worrying for the acknowledgement. So as soon as, so there are 3 variables as you see, SF, SN, the next frame to send. So SF and SF is all pointing to 0 here. He sends frame 0, he starts the timer. He sends frame 1, he sends frame 2. So when he sends frame 0, receiver is expecting frame 0, is getting frame 0. So he receives that, he sends acknowledgement asking for the next frame. So the Rn now is incremented, right? He has sent the acknowledgement asking for the next one, but the acknowledgement one is lost. He's getting frame one. He's expecting frame one. He's got that. His Rn value is incremented to 2, right? He's asking for ACK2, right? But the ACK2 is also lost. He's getting frame 2, right? He's getting his expected frame 2. He's getting frame 2. He's asking for ACK, asking for 3. But now what has happened here is, right? The timer times out. Yes or no? All the frames are sent, but the sender has not got the status of these, frames. So he has not got the, the status of the first outstanding frame itself. He started the timer. He started sending 3 frames. He's not got the status of those frames. His timer times out. So why is it called go back in? Is he has to now go back and start retransmitting from frame 0, frame 1, frame 2. But the idea now is when he goes back and retransmits starting from frame 0, Rn is pointing at frame 3. The receiver is expecting frame 3, the next frame. But what is he getting is frame 0. So he understands that it is a duplicate frame and he correctly discards that frame. So this logic works when your window size is 1 less than 2 power m. But let's look at what happens when the window size is exactly 2 power m. And in that worst case, right now he has the right to send 4 frames, frame 0, 1, 2, 3, without stopping and worrying for the acknowledgement. But all the acknowledgements are being sent, but it's all getting lost, right? So what happens? The timer times out and he goes back and retransmits starting from frame 0. But this time Rn keeps incrementing and now Rn points to the frame 0 in the next cycle. But the frame 0 that has been retransmitted starting from frame 0, right? The receiver now accepts this frame erroneously, thinking that this is the frame 0 of the next cycle. But the actual reality is this is the frame 0 of the first cycle. So that is why the window size should be 1 less than 2 power m, right? And not exactly 2 power m in the worst case where it could erroneously accept the frame matching with the next cycle for a sequence number, but that is not actually the case. It's a duplicate frame, right? I hope you understand why we have chosen this as the window size for the sender, right? But the receiver is expecting only 1 frame at a time. Okay, so let's go further now, right? So let me quickly take you to the algorithm of go back in so that you can understand this. So if you look at the go back in approach, there are 3 variables that are being used. Size of the window, which is 2 power m, 1 less than 2 power m. SF and Sn are initialized to 0, right? Because it is the first frame to send, it will be starting with frame 0, right? But now let's look at the sender side algorithm. Infinite while loop, you're waiting for an event. What kind of event can happen? A request to send event from the network layer. If you're getting a request to send event, yes, you can process it. There is no limit until or unless the window is full. So now you're checking whether your window is full. How are you checking your window is full? If your Sn minus SF, the next frame to send minus your first outstanding frame, if it exceeds your window size, if it's still equal to your window size, fine. But if it becomes greater, then you should not process that request. You should get into a sleep mode. You need to now get the status of your outstanding frames. Right? Till your window is full, not full, you can keep processing those requests and keep sending without stopping and worrying for the acknowledgement. But if your window is full, you've not got the status, you need to stop and stop worrying for the acknowledgements. Okay. So, okay. Now your window is not full. You're getting the request to send. You get the data from the network layer, make the frame, insert the sequence number for that frame, which is your next frame to send. Now, initially it is 0. So you make your frame numbered as 0. You keep a copy of that frame in your buffer. Frame 0 is kept in your buffer. And then you transmit your frame 0. You increment your value of your sequence number to the next sequence number. And this is basically modulo 2 power m. So when it reaches 2 power m, it again recycles to 0, right? Cycles back to 0. Okay, now look at this. This is the interesting thing here. Now, once it's only one timer that is there. So if your timer is not running, you start your timer, but you can keep sending your next set of frames, right? And track those frames. So this is for sending the frames. But now you get an arrival notification from the sender side of the physical layer. You have to expect an acknowledgement. So you receive the acknowledgement that you receive from the physical layer. You check whether the acknowledgement is corrupted. If the acknowledgement is corrupted, then you keep silent. and you're silent, your timer times out, right? So that's again another thing. But if you got an acknowledgement, you check the acknowledgement number in that acknowledgement and see whether the acknowledgement number is the next frame that you're expecting. If it is greater than SF, and if it is lesser than or equal to SN, the next frame that is sending. So it could also be a cumulative acknowledgement that I told you. So if you're getting an in-between acknowledgement number, which means that you can slide that many number of slots, right? Remove all the frames that you kept in the buffer and go on to slide your window. So that's where the sliding comes in. So look at this now. Your value of SF, right? So you're checking whether your acknowledgement number is actually lesser than, is basically greater than or equal to your SF. So if it's greater, which basically means that you could slide that many number of slots. Yes. So you purge those frames starting from SF, keep incrementing your SF to SF plus 1 till you reach your acknowledgement number. And once you've slide that many number of slots, right, you stop your timer. Because you got your acknowledgement before the timer times out, you can slide your slots, that many number of slots. And the next frame that you're going to send, you can again start your timer. So there's only going to be one timer that you keep stopping and starting, right? But in case, if you have not got your acknowledgement and the timer times out, or you got a corrupted acknowledgement, right? Your timer times out. You start your timer again, right? And you have to go back and retransmit starting from your SF value till the value of SN, how many hour frames that you have sent, right? You have to go back and retransmit. With that, this is one event. A timeout event happens. You have to go back from where you started, for which you have not got an acknowledgement, till how many frames you have transmitted. You have to keep sending all those frames. So this is the idea behind the sender side algorithm. I hope you're able to clearly understand this. From the receiver side, it's the same algorithm that you see with your stop and wait. There is no complications at the receiver. What the receiver is doing, right? It is only tracking one variable, only one slot at a time. It is expecting Rn, which is now initialized to 0. It's expecting frame 0 now. It gets frame 0. It increments the value of Rn to Rn plus 1 and asks for ACK1. Next frame. That's all. If it is getting any other frame number, it is not going to process. It is only going to process one slot at a time. So it checks whether an arrival notification comes. It receives the frame. If the frame is not corrupted, right, it's going to process it. If it's corrupted, it's going to be silent. His silence is going to worry the sender, right? As you know, the timer is being tracked here. But if one frame gets corrupted, but it gets another frame where the sequence number is not matching with the frame that is expecting, it is not going to process those frames. Those are out of order frames. It is just going to be discarding. It's only getting frame which is matching with that expected frame number. Then it processes that frame, delivers the data to the boss, increments the Rn to Rn plus 1, and sends an acknowledgement asking for the next sequence number. So this is only where in order frames are processed, out of order frames are discarded. I hope you're able to understand this. So let me look at now two examples to illustrate go back N approach. The first example, what we are trying to see here is the forward channel is good. My frames are going properly. Data frames are going properly. But the reverse channel is where the acknowledgement say it's getting lost or it's coming late, right? So here the scenario is just to explain you how cumulative acknowledgement, even if one acknowledgement is lost, the next acknowledgement can also act as cumulative to help you to combat that issue, right? So we look at that scenario. Okay, so all of you are here, right? Focused. Okay, so let's now look at this. Can you now look at this particular picture and tell me what is the value of M, the number of bits that I've used for my sequence numbering? Can anyone tell me this? And what is the window size that the sender is using in this approach? Can anyone tell me? Okay, so the window size here is basically 7. Yes, why it is 7? Okay, so if you look at M value is basically 2 bits. No, it's 3 bits. The range of sequence number that you see is from 0 to 7 and again cycles from 0 to 7. And sender window size is 2 power M minus 1. So the window size is 7. Receiver, the window size is 1. It's expecting the not frame. Now, what does it mean now? It can pump 7 frames without stopping worrying for the acknowledgement. So let's look at this here. What is happening is SF and SN are initialized to 0. The first outstanding frame that I'm sending is frame 0. I start my timer. I get a request event. I number it as frame 0. I started. I increment my SN to now SN plus 1. The next frame that I can send is going to be numbered as frame 1, frame 2, frame 3. It goes like that. But now let's look at this. One at a time, let's look at this. So frame 0 is sent. Receiver is expecting frame 0. It got frame 0. It is incremented the Rn to Rn plus 1. It is sending, asking for the next frame. Right? So ACK1. So when ACK1 is received, now the sender got the status of the first outstanding frame, it can slide by one slot. So if you now understand, if it slides by one slot, it can now further send one frame numbered as frame 7 now, right? So that slot is increased. So which means it can accommodate one more slot now, one more frame now. This is just for your understanding. But the idea now is you could keep transmitting your frames. So now frame 1 is sent. It's getting it expected frame 1. It's got frame 1. It is incremented Rn to Rn plus 1 and is asking for acknowledgement, asking for frame 2. But now what has happened is that ACK2 is lost. But things are okay because the data frame that the receiver expects is got. The acknowledgement is lost. So when frame 2 is getting, it is expecting frame is got frame 2. It is incremented Rn to Rn plus 1 is sending ACK3. Now before the timer times out, right? Now this sender has got ACK3. Right? So which means that he can now, he's already got now understood that frame 1, frame 2 is all received. And then they're expecting frame 3. So what he can do now, he can slide now by 2 slots at a time. So what's the model of the story here? Even if one acknowledgement is lost, the next acknowledgement acts as a cumulative for the sender to slide as many number of slots. And this happens before the timer times out itself, right? The cumulative acts as to ensure that it can continue. So in this case, what has happened now? Frame 3 is sent, right? Rn is expecting frame 3 is got, so he's incremented Rn to Rn plus 1. He's sending ACK4. Now the window is slided by one slot, so he can keep sending as many number of slots as the window size that is there. And when you keep getting acknowledgement, even if one acknowledgement is lost and the timer is not timed out, you could that the next acknowledgement can act as a cumulative there. But the real aspect of why it is go back in can be understood when your data frames are getting lost that you're transmitting. So let's look at one scenario now. So if you look at in this case, what has happened here is your sender side, there is a problem when you're transmitting your data frames. So same window size, same sequence number being used. Now the sender is sending frame 0, first outstanding frame. Receiver is expecting frame 0. It's incremented Rn to Rn plus 1, asking for ACK1. But now you know that he can actually keep sending frames without stopping and worrying for the acknowledgement. So he sends frame 1, frame 2, frame 3 without stopping and worrying for the acknowledgement, right? But the timer has started. He's sending these frames. But what has typically happened is frame 1 got lost. Though the receiver has not got frame 1, he's got frame 2 successfully. What the receiver is expecting is frame 1 and he's getting frame 2. So what will the receiver do in this case when he's getting an out of order frame? Receiver only expects in order frame. So he will discard that frame. He's going to be silent. He's getting frame 3. He's going to discard that frame. He's not going to do any action. So this guy's silence is going to basically worry the sender. The sender is transmitting frames, but he does not got an acknowledgement, right? His timer times out. So what he has to do now when a timer times out, whatever outstanding frames has been sent, he has to go back and retransmit in consequence of that timeout. He has to now stop, right? And retransmit starting from the SF value till the SN, whatever that he has sent. So you send 3 frames, right? So you go back, send, retransmit all those 3 frames without stopping and worrying for the acknowledgement. So when frame 1 is resent, receiver is expecting frame 1, he's got frame 1, he increments Rn to Rn plus 1, he's sending ACK2 asking for frame 2. He's getting frame 2, right? He sends ACK3. He gets frame 3, he sends ACK4. But if you look at this, the ACK2 is not processed immediately because this guy is sender is busy in sending all those retransmissions. So only after he completes all the retransmissions, then only he starts processing the physical layer even. So there is a delay in processing the ACK's acknowledgement. So as and when he gets an acknowledgement, he keeps sliding the window by the slots, right? When ACK2 is got, he slided by one slot, then ACK3 another slot, then ACK4 another slot, right? So that's the idea behind go back in. So go back in is stop if your timer times out, you have to go back and retransmit from SF till SN, whatever that you have transmitted. But if you carefully look at it, there is a major flaw here, right? The receiver, what he could have done, he has basically discarded all the correctly received frames because it is out of order. And so though only one frame got lost, the sender is now forced to go back and retransmit everything. All these are duplicates again that he has to keep transmitting. And so if we can address that issue, and instead of going back and wasting the bandwidth of retransmitting all the frames that are there, if we can address that, that is where the next protocol comes in, which is selective repeat ARQ protocol. So we'll give a pause here. I hope you're able to understand this go back in approach. Right, this is for those who missed the class of go back in. I hope this gives you an idea so that we can understand selective repeat here. But go back in is nothing short of stop and wait. The only difference with stop and wait and go back in is in stop and wait the sender window size is 1. In go back in the window size is 1 less than 2 power. Yeah. Okay, so though go back in is better than stop and wait because it keeps the sender busy. It occupies the bandwidth by filling in the pipe. But the only problem is if the channel is a noisy channel, even if your first frame is lost and all the frames that you've transmitted, everything you have to go back and retransmit, right? Because the receiver does not accept out of order frames, right? So that is the problem. So it could potentially waste a lot of bandwidth if the error rate in the channel is high and it has to retransmit everything. Okay, so thank you for your patience. Let me stop here before we continue select to repeat the next video.